A moment of wonder. A single biological cell contains over 100 trillion atoms. Whether you are looking at a living, breathing organism or a non-living piece of rock, the object is built from the exact same microscopic particles. We experience the physical world as strictly solid and endlessly diverse in its textures and shapes. But the actual building blocks constructing that reality are incredibly simple and overwhelmingly empty. To understand how the physical universe actually operates, we have to strip away the macro world and look closely at the strict recipe of a single atom. Every object you can touch or see is simply a variation of one rudimentary blueprint. This diagram outlines our ingredients. The proton carries a positive charge of 1 and a relative mass of 1. The neutron has the same mass of 1, but 0 charge. The electron carries a negative charge of -1, and its mass is effectively 0. Positive, negative, and neutral. These three contrasting pieces are the only raw materials the universe uses to construct physical matter. To assemble an atom, you follow a strict construction rule. The heavy protons and neutrons are packed tightly together into a dense central ball called the nucleus. The tiny electrons do not sit in the center. Instead, they fly constantly around the nucleus in outer rings called shells. This scale comparison graphic maps out the physical reality of that assembly. An entire atom measures about 0.1 nanometers across, but the central nucleus is 10,000 times smaller than the total width of the atom itself. It operates much like a solar system, one dense object in the middle, smaller objects in vast orbits, and between them is almost entirely empty space. When you press your hand against a wall, it feels completely solid, but that solidity is a physical illusion created by tiny objects orbiting vast empty distances at incomprehensible speeds. In a standard atom, the accounting is perfectly balanced. The number of positive protons exactly matches the number of negative electrons, canceling each other out to create a neutral baseline. This diagram shows an atom in perfect electrical balance. If it gains an extra electron, negative charges outnumber positive protons, tipping the scale to create a negative ion. Conversely, losing electrons means positive protons outnumber negative electrons, tipping the balance to leave a positive ion. Breaking this balance does not change what the physical object actually is. It only shifts its electrical charge, tilting it like a microscopic seesaw. If every single piece of matter is built using the exact same 3 particles, why does oxygen behave so differently from lithium? The defining factor of any element in the universe is exactly how many protons sit inside its nucleus. This high-contrast grid is the periodic table. It functions as the universe's master catalog, tracking these specific proton counts element by element. These 2 layout boxes are the nuclear symbols for oxygen and lithium. They provide a readable blueprint for how each specific element is constructed. The number in the bottom left corner is the atomic number. This tells you the exact number of protons inside the atom. That count dictates the element's identity and sets its baseline number of electrons. The number in the top left is the mass number. This represents the total amount of heavy material packed into the center of the atom, combining both the protons and the neutrons. You can use these 2 numbers to find the exact count of hidden neutrons inside the element. By simply subtracting the bottom atomic number from the top mass number, in lithium's case, 7 minus 3, you discover it has exactly 4 neutrons. The staggering complexity of the physical universe is ultimately governed by elementary arithmetic, relying entirely on just 3 microscopic pieces of matter.